All right, and we're on to part 2 of 5.3, excuse me. Still working on trig functions, okay? So today we're doing reference angles. So a reference angle, for an angle theta, written theta prime, this is read as prime, is the positive acute angle made by the terminal side and the x-axis. So when we find reference angles, it is always found in reference to the x-axis. Always, always, always. Never the y-axis. It's a really common mistake. Always the x-axis. Okay? So what it means is, in general, for 294, what you're going to do, I don't know why this box is right here, but what you're going to do is you're going to draw that angle. So remember, this is 190, 180, 270, so 294 is going to be somewhere over here. So it's going to be, what, 270 plus 24? Okay? So that's the angle. But the reference angle is going to be the one, find the closest x-axis, so that's right here. What is this green angle right here? So that green angle is going to be 360 minus 294, which is what, 66? And that would be your reference angle. Okay? It's the angle that this is right here. That little angle right there. Okay? So for 294, it's 66. For 883, let's do the same process. 883 going around twice is 360, right? So 1, 2, we're around twice at 360 at 720. And if you take 883 minus 720, left with 163, which is like right here-ish. Okay? So what we're looking for now, find the closest x-axis. It's not here, so it's here. And we're going to look for what this angle is right here. So we said this is 183. So we're going to take 163. That makes sense. So we're going to take 180 minus 163, and that's what, 17? That's what that degree needs to be right there. Okay? So it's not too bad. But what it turns out is that most of the properties of the angle match that, at least with an absolute value, to those of the reference angle. So we'll be working a lot with these. Okay? So in this table here, just quickly enough, if you're looking at this and we have it in quadrant 2, okay, the reference angle for this is going to be 180 minus, say this is a nice little chart if you want to check it, right? Because we take this 180, that's this angle is right here, minus where we're at, which is theta, and that'll give us theta prime, which is the reference angle. Okay, for quadrant 1, right now we're just going to take whatever theta is. That's the same thing as theta prime. Okay, because this right here is our closest reference, which is how you normally make angles, right? For this one, we're going to actually take and we're going to go theta, whatever it is, what is that there? Theta minus 180, because we're a little bit closer up here. We can't take this, subtract this, so we're going to take whatever we have and subtract off theta, and that'll give us theta prime. Okay, and for the last one, like we just did, we're going to take 360, which is up here, and we're going to subtract off our theta, and that'll give us theta prime. So it's a little cheat code right here if you want to see how to find reference angles. Okay? You'll get the hang of it pretty quickly. So let's use some reference angles. Okay? So we want to find the 6 trig values for the angle 225 degrees. Okay? So we want to do, if you think about 225, right, 90, 180, 270, so it's somewhere between these two. Okay? Instead of finding the trig values of 225, we're instead going to find the trig values of whatever the reference angle is. So our theta prime, if you look at the previous page, right, we're in quadrant 3, so we want to do theta, 225, minus 180, which is 225 minus 180, it should be 45, but 45. So our reference angle right here is 45 degrees. Okay? And so what we're going to do is we're going to pretend here. So I'm just drawing a lot of pictures. So what we have for our angle, right, so it's like this, it goes all the way around, but we're going to pretend like we are 2 out. Is that what I want? No, it's not. We're going to go root 2 out as our r. And this is going to be 1 and 1. Okay? That was our special triangle, right, for 45, 45, 90. This is a 45. Okay? So now we have our 1, 1, root 2 triangle, and we're going to treat that the same. Now we know that down here, we're in quadrant 3, right? So remember the the cheat code. It was all students take calculus. Everything's positive right here. Sine's positive, tangent's positive, cosine's positive. So down here, only the tangent's going to be positive, which means both sine and cosine are negative. So it doesn't matter what we get here. Our sine and cosine need to be negative. So you need to keep track of where things are positive. There's that chart from 5.1 or 2, whatever one that was, that you could use. But in general, we're going to look at what this the sine, cosine, tangent, and secant, cosecant, and cotangent of 45 are, and then use the proper sign to get the right answer. Okay? So here, our sine of 225, remember we're still working with this. So the sine of 45 is 1 over root 2, which is root 2 over 2. But the sign needs to be negative. So there's our answer, negative root 2 over 2. Okay, look back at that chart from the part 1 of 5.3 to figure out how to get this work right. You just take 1 over root 2 times root 2 over root 2. Simplify, right? Okay. Cosine of 225, that's going to be, cosine is 1 over root 2, so same thing. Again, negative. And then the tangent of 225 is going to be 1 positive. Okay. Now we do the same thing for opposite of sine is cosecant of 225. What we're going to do is we're going to flip this. We have 2 over root 2. So it's going to be 2, what is that? 2 root 2 over 2. Still negative if you flipped it. Okay. For the next one, you get the same thing. For secant, it's going to be 2 root 2 over 2. Oh, 225. But negative. And for the cotangent of 225, you will again get 1. Okay? So all we did there was take that chart, find the sine cosine of 45, right? And then we're going to use that and then the appropriate sign, right, the plus or minus, from the quadrant that we're in. Okay? So here's the steps that we just went through. Step 1, if theta is bigger than 360 or less than 0, so if it's like 720 or if it's like negative 50, find a coterminal angle, right? So we did talk about that earlier, but basically spin in that circle until you reach that coterminal angle, and then you have arrived at your angle. Find the reference angle, theta prime, okay? Do that using that chart. So in our case, we found 45 as a reference angle. Find the trig functions for the reference angle. So we found all the trig functions for 45 degrees from that table, from 5.1 part 5.3 part 1, and then determine the correct signs for the values found in step 3. So there's that table signs earlier, or using this trick, all students take calculus, whatever you have to do, that'll give us the 6 here, okay? It's kind of an involved process, but it's a really, really good one to get in the mindset of, okay? So let's use this, an example 6 here. Find the exact trig values of the following expression. So we're looking for the sine of negative 150, okay? So what we're going to do is we're going to find the coterminal angle. So we're going to do negative 150 plus 360 just to get inside of 0 to 360. So that is, what, 210? So this is sine of 210. Those are the same angle. Okay. So the sine of 210, so 210 falls in quadrant 3, right? Now we have to find the reference angle. So in quadrant 3, the reference angle can be found by doing 210 minus 180. That'll give you 30. So basically this is going to be the same value as the sine of 30. From that chart from day 1, the sine of 30 should be 1/2. Yeah. So we get sine of 210 is the same as the sine of 30, which is 1/2. And now we just need to discuss the plus or minus. We're in quadrant 3, right? 210 is in quadrant 3. And so the sign needs to be negative. So we get negative 1/2 as our answer. Okay? Lots of stuff there, but overall, nothing too bad. Okay, I think I'm just realizing up here that I completely butchered this. If you do this, these cancel, and it's just root 2. I don't know why I wrote 2 root 2 over 2. Sorry about that. Okay, make sure you cross those out. Okay, negative 1/2. For 780, again, find a coterminal angle. So this is step 1. Okay, so here are the steps for you. Step 1. We're going to do 780, and we're going to subtract 360 until we can stop. So 780 minus 360, you can do it twice. So it should be 60 degrees, right? Because 780 minus 720 is 60. So we have found step 1. Step 2, okay? 60 degrees is a completely fine angle, right? So that is it's in quadrant 1. So that is our reference angle. Theta prime is equal to 60 degrees. Okay? Step 3, we want to find the cotangent of 60. So I'm going to write this out. Cotangent of 60. By that chart, cotangent of 60 is root 3 over 3. Okay? And step 4, we have to think about where we're at. So we are in quadrant 1. The cotangent is positive. So our final answer for the cotangent of 780 should be positive root 3 over 3. Okay? So those are kind of all the steps really slowed down for you. Make sure you practice this. It's not something that comes super quickly, but it's not too bad in general. Okay? And on to the last page of this video. We're looking to find all the options for theta if theta is in a certain interval. Okay, so we're looking for theta in between 0 and 360, non-inclusive, where the sine of theta is negative. Okay, so there's going to be a couple options for this. So here's what you need to be doing. If the sine is negative, remember this little trick. All students take calculus. If the sine is negative, that can only happen in 2 quadrants. So since sine is less than 0, we are either, so we're in either, so sine is negative. So it's positive here and here. So we're in quadrant 3 or quadrant 4. That's where it's negative, right here. Okay? So we know it's in quadrant 3 or 4. Now if you look at just the number, you can get rid of the sign. We know the sine is root 3 over 2. Okay? So if you look back to that chart from 5.3 day 1, or part 1, look back to that chart where the sine was root 3 over 2, that only existed at 60 degrees. So it must be our reference angle of 60 degrees. Okay? So we know that the reference angle is 60 degrees. Okay? So basically what we've done is we're in quadrant 3 or quadrant 4 with a reference angle of 60 degrees. That's all the information that we know. So we kind of have 2 options. We're either 60 degrees from here, or we are 60 degrees from here. Those are our 2 options. So option 1, this is 180 plus 60, that is 240. Or we are at 360 minus 60, or 300. Those are the 2 options of things that'll work. So again, look at what your sign is. Is it positive or negative? Where can that happen? Okay. Then, what does your reference angle have to be to get this value? Figure it out from there. Okay. That's all there is to it. And now to the easiest part of the day. We're looking at the approximations with a calculator. Okay. So I have my calculator from when I was like 12 right here. Any calculator works, whether it's online or not. But most calculators only have sine, cosine, and tangent as buttons, right? For an obvious reason. For the other 3, you can just do the reciprocal of it, right? So if you have like a sine, you could do 1 over, and you did cosecant, you could do 1 over sine, get the right answer, okay? So here's what we're going to do. Practice just plugging this in. So this is supposed to be minutes. I don't know why it's cents. Okay, so it's 68 degrees, 43 minutes. So for this one, a little bit of extra work, right? We need to convert it. So we have 68 minutes, 68 degrees, 43 minutes. That's the same thing as 68 and 43 over 60. What is 43 over 60? I don't know. Approximately 68.71667. Let's do that. Okay, close enough. Okay? So all you got to do is, on my calculator, I have to type in 68.71667. And then I have to type in tangent. Okay, yours might work a little bit differently. Each calculator works a little bit differently. The biggest thing, so like on mine, if you look, it's kind of hard to see under this, but you see it says degree right there. Make sure your calculator is in degrees mode. If you don't know how to check that, or if you're on Google or wherever you're at, it's got to be in degrees. If you don't know how to check that, ask me, okay? Because there's 2 ways to look at measurement of angles. It's degrees and radians, and a lot of the defaults of calculators is in radians. So make sure you have it in degrees. I do, and so I just get this tiny little angle, or I get this tiny little value of 2.567. I'm going to round down at 1. Okay, it just says approximate. I'm not rounding really anywhere specific. I just rounded when I saw the first 0, but 2 or 3 is usually a good bet. Okay, you want to round as little as possible. Okay, part B. 193.622 hit cosine. I get negative 0.97187. That's my value. Okay, that one you can just plug in right enough into it. Now for this one, for cosecant, no converting or anything, but there's no cosecant button, so I do 1 over the sine of that same value, 35.8471. So I should find out what that is. On my calculator, it's, if you have a fancier one, you can do all this in one step. I don't have a fancier calculator, so I type it in, push sine, until this is the same thing as 1 over 0.585624, which is 1 divided by 0.585624. I get 1.7076. Okay? That's going to be a little bit different than yours if you can do it all in one step there, right? Because I had to round right here, because it just keeps going. So you're going to get a little bit different answer, but it's close enough. Okay? And for secant, this is the same thing as 1 over cosine of the same answer. The same process here. So 287 negative cosine is 1 over 0.29237, which is 1 over 0.29237. 3.42. Good enough for me. Okay? So those shouldn't be too bad. I trust that you know how to operate a calculator or can figure it out. Okay? Make sure you convert it to to decimals if it's in minutes, but outside of that, nothing too crazy there. Okay? We have one more video for this section and then we're done. Thanks for watching.